Okay. Okay. First of all, I would like to discuss about something due to okay. This solution to last week quiz. So the first one, you have to be careful when solving x squared minus 4 equals 0. So which x satisfy x squared minus 4? That you have 2x. Why? Because you can simplify this, you can factorize this. To become this. And you have x equals minus 2 and 2. So x equals minus 2 and 2 satisfies this equation, x squared minus 4 equals 0. But this is not the same as solving x equals square root of 4. X equals square root of 4 is only 2. So be very careful, And you always use full sentences to answer questions. Number 3, pay attention to the units used. Okay, when solving integral questions which are related to area, sketch the graph first. Sketch the graph first. You have, although it is a rough sketch, you have to have the main point. So if you have x plus 1, so you have this. X plus 1. Why? Because if you have x plus 1, it says that the intersection point is 1 here. So the main, you have to have the main attribute of the graph. Y equals x plus 1, so you have the slope will give you 1. The slope will give you 1, So you cannot have this one. Or maybe this one. It's too rough, this one. This is wrong because the slope is negative. Very, very careful. So if you are draw it roughly but right, you can identify which one is the boundary, which one the upper and lower functions to be integrated. That is what we usually call integral. So you have to identify if you are given the area between two curve questions. So you have to identify which one is the upper and which one is the lower. So the area is given by integral of upper minus lower. Do not forget about that, And carefully write the notation integral fx dx. Carefully write the integral notation. Some of you leave out. Some of you leave out the dx. Don't forget this is integral fx dx. Don't forget what is this? This is the height. What is this? This is the width. So this is fx. So we are calculating the area of rectangle area. So the height is given by fx and the width is given by dx. So this is just counting the area of rectangle and you sum all of the rectangle. So you got the area. That's all. We will Korean. So do you have any questions about the quiz? No, I will like to proceed to integration by parts technique. So this is the last technique. So first of all, you are given that you can do the integral directly. This is direct method. If this is if your question is not in the table, so if you have this one, 2x plus 1 to the power of 5 dx, you cannot have direct method. Why? Because this is different with this. If you have this is the same, x and x, but this is different. So you cannot have direct method. So to questions like this, you know that you have to use substitution method. Substitution method, you let u equals to x plus 1. So in the end, you want to change this into something, a constant, times u to the 5 du. So what if I cannot solve this directly? I cannot use substitution, what else can I use? That is what we usually call integration by parts technique. Integration by parts technique. Maybe I will give you some quick formula, yeah, quick formula. So integral e to the ax plus b dx. Okay, yeah. This is what? This is 1 over a e to the ax plus b plus a constant. Why? You can differentiate this. What is the differential of this? The derivative of this? 1 over a times the derivative of e to the power of ax plus b. What is the derivative of, yeah, you can imagine this just like square, yeah. So what is the derivative of e to the power of square? This is e to the power of square, but don't forget we want to have the derivative with respect to x. So I have to multiply ax plus b with the derivative of with respect to x. That is a. So a and a cancels out. So you have the integral. Sorry, your questions.
Boleh ke bawahan dikit nggak Pak? Di screen saya kelihatan.
This one?
Ya, betul Pak.
Okay, yeah. Okay, good. So integral of you have 1 over a. So this is the formula, yeah. This is formula. Why? Don't forget this is calculating the antiderivative. So when you wonder is this formula correct or not, you can just find the derivative of the right hand side. The derivative of this is 1 over a e to the square times the derivative of the square with respect to x, that is a. And a plus 0, yeah, constant, the derivative is 0. And a cancels out, so I have e to the power of ax plus b. So this is a right formula. Okay, yeah? And then later we will deal with this. Integral ax plus b to the power of n. Okay, yeah? Dx. What is this? This is 1 over n plus 1 ax plus b to the power of n plus 1. The same, yeah? But you have to add 1 over a. So this is the formula also. This is the second formula. Yeah, you can memorize or you can use substitution method. If you use substitution method, you will end up with this formula. And if you use substitution method, you will end up with this formula. Don't forget that this is for ax plus b. What if this is ax squared? It is not. So it should be x to the power of 1. And a and b is just a constant. So you have this one. Is this a real formula? Yes. Let's try to find the derivative of this. This is a constant. So 1 over n plus 1 times 1 over a times the derivative of this. What is the derivative of this? Ax plus b to the power of n plus 1. So you will have, sorry. So you will have, what is the derivative of this? 1 over n plus 1 times 1 over a, this is just a constant, times the derivative of this. The derivative of this, ax plus b to the power of n plus 1, the derivative is n plus 1 times ax plus b to the power of n. If the derivative with respect to the square. But you want to find the derivative with the x, so you have to multiply with a. So a and a cancels out, n plus 1 and n plus 1 cancels out. This is plus 0, okay? So the derivative of this is ax plus b to the power of n. Yes. Okay, so the antiderivative of ax plus b to the power of n is 1 over n plus 1 times 1 over ax plus b to the power of n plus 1 plus constant. Okay, you can add these two formula, or you can you can memorize, or you can use the substitution method to look at this formula, yeah, to prove this formula. Okay, And now I just want to look at some things that is the integration by parts technique. So I want to find the derivative of the multiplication of u times v. The multiplication of u times v, what is the derivative? U prime v. What is u prime? U prime is the derivative of u with respect to x. The derivative of u with respect to x, u prime v, plus u v prime. What is v prime? dv dx, the derivative of u with respect to x. Okay, yeah? If I consider this is just a division of differential, I can multiply by dx, so I have this one, the second row. Okay, yeah? The second row. So I can tidy it up a bit, so I have the third row. Why? Because I want to integrate this, yeah. I want to integrate both of the left-hand side and the right-hand side. So it will give you this, it will give you this. And what about this one? Integral dy. This is 1. What is function that has the derivative if 1? X, but the variable is y, so it should be y. Okay, yeah. What function the derivative is 1? X, but the variable is u times v, so you have uv here. Okay, so integral of this 1 d this is capital X. Okay, so you have integral 1 duv is uv, and you have this one. Okay, and you can move this, the first term, to the left hand side. So you have uv minus integral v du equals integral u dv. So this is what we usually call the integration by parts technique. This one, this formula is usually called the integration by parts technique. How do we can solve using this one? This is the famous one, yeah. Some of you have already asked, but what if I want to find integral of ln x dx? Okay, yeah. Okay, and then what do I have to do? I have to let this as u and this as dv. Okay, yeah, to fix to the formula, to use the formula. And to use the formula, I have to find v, given dv, I have to find v, and given u, I have to find du. So u is ln x, dv is dx, so I have to find du. So du dx, derivative of u with respect to x, is 1 over x. So du equals 1 over x dx. What about dv equals x? dv equals x dx. I can integrate both of this, so it will give you v equals x. Yeah, plus constant, but in integration by parts technique, we will leave out c. We will leave out c. So v equals x. Okay, yeah. So integral u dv is u is ln x, v, don't forget to use parentheses. Use parentheses. If not, you will mistakenly look at this as ln x times x. So you will have ln x squared, and that is wrong. Okay, u times v minus integral of v du. And x times 1, this is cancels out. So you have x ln x times ln x, minus integral 1 dx. Integral 1 dx is just x. So you have minus x plus constant. So do you have any questions here? So we are just applying the formula. Integral u dv equals uv minus v integral v du. We just substituting it to the formula. You have to memorize the formula, yeah? Just memorize the formula. But if you don't want to memorize the formula, yeah, do hundreds of exercises, and you will memorize it by your eventually. Okay, this one, find integral x ln x dx. So this is x times ln x, yeah, x times ln x dx. Okay, so what can I do? I can let u equals x. So this one equals u and the rest is dv. Okay, and the formula give you, don't forget, if you are using formula, we will give you mark in the exam. Okay, uv minus integral v du. Okay, so you have u, you have dv, you have to find du, and you have to find v. So u equals x and dv equals ln x dx. What is du? Okay, you have, if you have du equals x, then du dx is 1. It will give you du equals dx, yeah? You just multiply it to the other side. So you have du equals dx, and what about this? Integral ln x dx, so I have to integrate both of the left hand and right hand side. Integral of dv is v. What about integral ln x dx? Yeah, I have the previous one, this one. So this is x ln x minus x. We leave out the c. Okay. And what is the integral of this? This is u times v minus integral v du. Du is dx. Okay. Okay. And then I multiply it one by one. This is x squared ln x, the first term. The second term, x times x, this is minus x squared. Okay, I can simplify this. Minus integral x ln x, minus plus integral x dx. This one and this one. Okay, so you have this. Okay, I can tidy it up a bit. X squared ln x minus x squared. I don't know this because this is the equations. Minus integral x ln x dx. What is integral x dx? This is a half times x squared plus a constant. Okay, so you have this and this. Okay. Oh, okay. I want to tidy it up a bit, and I have this one. Because this is minus x squared, this is a half x squared. So if you add it up, you will have minus a half. Okay. And then, don't forget, this is integral x ln x dx. So this is the same. This one is the same as this. And this is 1. So I can get to the other side. I can get to the other side. So 1 of this plus 1 of this, it will become 2 of this. And you have the rest is the same, the remains is the same, x squared ln x minus a half x squared plus a constant. I want to find without 2, so I divide all with 2. So you have this one equals divided by 2 a half x squared ln x divided by 2 minus 1 over 4 x squared plus c divided by 2. But c divided by 2 is just another constant. So I will just write down a constant, another constant. You don't have to specify. So do you have any question from this? This is a rather tricky. This is a rather tricky. Okay, look at this one. So I have now, I want to find the same integral, but I will have another, I want to choose another u and another dv. So u is now ln x and dv is the rest. What is dv? dv is x dx. This is u, so this is u. And this is dv. This is dv. And this is u. Okay. Okay. And then I can find out that du equals 1 over x dx. Okay. Because du dx is 1 over x. So du equals 1 over x dx. And what about the v here? I can integrate both of the side. So I have integral dv is v, and integral x dx will give you a half x squared plus constant. We leave out the constant. Okay, and I can use the formula uv minus integral v du. U ln x v minus integral v du. Okay, yeah? Okay, and then I have this one, a half x squared times ln x is this one. Okay, yeah? I can tidy it up a bit. A half can get out from integral, minus a half. X squared and x is cancelled out, so I have integral x dx. And what is integral x dx? Is a half x squared plus a constant. So you have this times this. So you have in the end is this. More shorter way. Shorter way. This is alternative answer. Shorter way. Okay, this is a longer one. And it's very complicated. Why? So because you have to find what is integral ln x dx. What is integral ln x dx? Example 1. So it's a little complicated. So if you choose wisely, what is u and what is dv, you have the shorter one answer. You will have a shorter one. The answer is shorter. Okay. So in the end, for integration by parts, you have to choose u and dv wisely. If not, the problem will get a little bit complicated. How can I choose wisely, Pak? Of course, exercises. I can say no more. Exercises. I'm sorry. Yeah. Okay. This one, example 2. This is x times e to the power of minus x. Okay, yeah. Can I use this one, u equals minus x? Can I have this one? I want to use substitution method. Let's see. So it will give you integral of something. Okay, yeah. X, this is minus u. E to the power of minus x, e to the power of u, dx minus du. So you have the same problem. You have the same problem. Yeah, this is the something u times e to the u du. Yeah, this is the same problem but different variable. That's just all. So you cannot have substitution method here. For the example up, this one, example 1 and 2, you cannot also use the substitution method. Okay, so let's see. How do I choose u and v? How do I choose u and v? Let's first, I have u is e to the power of minus x. This is u. And the rest is dv. The rest is dv, x dx. And you have to find the derivative, du equals. Okay, yeah. What is the derivative of e to the power minus x? What is the derivative? Is e to the power of minus x. Don't forget if the derivative with respect to cap square. But if you want to have the derivative with respect to x, you have to find the derivative of minus x with respect to x, that is minus 1. So here you have this one, minus e to the power of minus x. Okay, what is v integral? If I integrate this, integral dv is v, integral x dx is half x squared plus constant, we leave out the constant. Okay, yeah. So I can look at this, integral x, this is u dv evaluated at 1 and 0 plus integral v du. Okay, yeah. Unfortunately, it's getting worse. Why? You look at this. This is just a half integral 0 to 1 x squared e to the power of minus x dx. It's getting worse. Why? Because the first one you have x to the power of 1 and now you have x to the power of 2. If you do this again, you will end up with this x cubed e to the power of minus x dx. If you do this integration by parts once again, you have integral x to the power of 4 e to the power of minus x. And you cannot do anything. But if you choose wisely, you let u equals x, and dv is the rest, e to the power of minus x dx. So du dx is 1, so du equals dx. And dv, what is the antiderivative of this? Remember, integral of e to the power of ax plus b dx. This is just 1 over a e to the power of ax plus b plus constant. So integral of this is just 1 over a here is minus 1 because this is just minus 1x plus 0. This is ax plus b. So you have 1 divided by a times e to the power of ax plus b. This is e to the power of minus x. So you have minus e to the power of minus x dx. Okay, yeah? By using the quick formula. So you have, what is this? uv, ux, uv, v is this. Don't forget the minus is in front. Minus e to the power of e to the power of minus x, evaluated at 0 and 1. Okay. Minus integral of v. Don't forget minus will give you plus. Minus. Integral minus plus e to the power of minus x du dx. So you have this. And you can just substitute this. X equals 1. So minus 1 e to the power of minus 1. This one. Minus 0 e to the power of minus 0. E to the power of 0 is 1, but you multiply it with 0. So you have 0. Okay, yeah? And what is the integral of this? The same as this. The integral is the same as this. Minus e to the power of minus x, evaluated at 0 and 1. So you have minus e to the power of minus 1, minus, don't forget, minus e to the power of 0. Be very careful, yeah? Parenthesis. So you have this, I can tidy it up, minus this, plus minus this, plus 1. So you have 1 minus 2. This is wrong, yeah? 1 minus 1 over e, 1 minus 1 over e. So you have 1 minus 2 over e. Okay, yeah? So you have, in the end, you have to choose wisely. Choose wisely. How do I choose wisely, Pa? Yeah, exercises. I'm sorry, but exercises. Yeah. Now number 4, x squared e to the power of minus x. Based on our experience here, we have to use dv is e to the power of minus x dx. So this should be dv and this should be u. Let's try. U equals x squared, dv is e to the power of minus x dx, du is 2x dx, this is the derivative. And what is v is the integral of this. This is minus e to the power of minus x. Okay, yeah? And so you have, what is integral is uv, 2x times this. The sign comes in front, minus x squared uv, x squared times e to the power of minus x, evaluated at 0 and 1, plus, don't forget, yeah, for indefinite integral, if you have the boundary, you cannot have the constant. Don't forget, yeah, you don't have the constant if you have the boundary. So you don't have constant here. Okay, yeah? Plus integral v, oh, this is minus, yeah? Minus, so you have plus e to the power of minus x du is 2x dx, this one. So you have minus, you substitute 1 and 0, you have this, plus 2 can get out from integral. But integral of this, we have learned this at example 3. This one. 0 to 1. So I can just substitute this 1 minus 2 over a. This is 1 minus 2 over a. Okay, so you have 2 minus 5 over e. Okay, yeah. So one of the function of integration by parts is what we usually call reducing technique. Reducing technique. So if you have integral x squared e to the power of minus x dx, with using the wise choice of integration by parts, I can bring it to this form. If I can use integration by parts again, if I use integration by parts again, it will become e to the power of minus x. You see, this is reducing from x squared to x to 1. And if 1, you can do this. The same. If you have integral x ln x dx, you can use integration by parts to have this one, integral ln x dx. And you have ln x dx. What about x squared, Pak? Yeah, the same. The same. If you use integration by parts, it will become integral x ln x. If you use 2 times, it will become integral ln x. But yeah, we have a better alternative solution, yeah, for the ln x. Example 5. Okay, do you have any questions here? So we are just using the formula. We are just using the formula. We are just applying to the formula. Don't forget, if you have this kind of problem, don't forget, write down the formula. Write down the formula.
Pak, may
Okay,
I?
Yes, questions, your name.
Felix, Pak.
Yes, Felix, questions.
For the example 4, if I'm not mistaken.
Example 4, yes.
Itu kenapa bisa jadi minus e minus x ya?
Very good question. Very good question. Thank you. Thank you. So I will explain it again. Hey, sorry. Based on this, Felix. So if you have integral e to the power of ax plus b dx, it will give you 1 over a e to the power of ax plus b plus constant. You can prove this formula by using substitution method, that this become u and you have this one. Okay, yeah, you can use substitution method. Okay, yeah, but I can use it directly. You can just memorize this. So if you have integral of e to the power of minus x dx, this is integral of e to the power of minus 1 x plus 0 dx. Can you follow me, Felix, here?
Okay.
Minus x is minus 1 times x plus 0. Can you follow me?
Yes, Pak.
Yeah, okay. So this is A, and you can just use the formula here. So you have 1 over A is minus 1. E to the power of ax plus b, that is minus x, plus constant. We leave out the constant for integration by parts. So you have 1 divided by minus 1 is minus 1 times e to the power of minus x. It will become minus e.
Min 2. Yes.
Okay, yeah? Okay.
Thank you, Pak.
And this applies also if you have ax plus b to the power of n dx, it will give you 1 over n plus 1 ax plus b to the power of n plus 1 plus constant. Okay, but just for a linear one, if this is changed to ax squared, it doesn't work. If this is changed to ax squared plus b, it doesn't work also. This is just a special formula, Okay, I just give to you because this is special and you are special.
Thank you.
Okay. Let's carry on. Example 5. So I want to find this. Okay, I know this is the same as integral x times the square root of x plus 3 dx. So I can use this u, this become dv. I want to use integration by parts technique. And then u is equals x, dv is the rest, 1 over the square root of x plus 3 dx. Okay, yeah? And you have du is this. What about the integral? Integral dv is v. And integral of this, okay, yeah? This is integral x plus 3, 1 over x squared plus 3, okay, yeah, dx. Is integral of this. V is integral of this. Okay, yeah? I can use substitution technique, that is a equal x plus 3, then dA equals dx, then V, this one, 1 over this equals 1 over square root of a is x plus 3, dx is dA, so I have this one, so this is just a to the power of minus a half, so I have this one, and this one in the end, and I can leave out the constant. But with the formula, I can do this more easily. So you have integral 1 of square root of x plus 3 dx. And this is integral x plus 3 to the power of minus a half dx. But this is just integral of ax plus b to the power of, yeah, this is n, yeah, to the power of n. And I can substitute this formula. So I have what I have, 1 over a, oh, sorry. This is, you should have 1 over a, yeah? So 1 over a, this is 1 times x. 1 over a, this is 1, times ax plus b, this is x plus 3, a is 1, and b is 3, to the power of n plus 1. This is minus a half plus 1. Sorry. Let me do this again. Hey. Yes. So the integral will give you, okay, yeah? So this is a equals 1, b equals 3. So you have, by the formula, 1 over a, 1 over 1, times 1 over n plus 1, 1 over n is minus a half. Okay, yeah? Time ax plus b, a is 1, xb is 3, x plus 3 to the power of minus a half plus 1, that is a half, plus constant. So you have 1 divided by minus a half plus 1 is a half. So you have 1 divided by a half is 2. So you have 2 times square root of x plus 3 plus constant. The same. Okay, yeah? So you can just use this formula. I will use this. I will tidy up a bit. So I have integral ax plus b to the power of r dx. It will give you 1 over a, the same like e to the power of ax plus b, yeah? 1 over r plus 1, ax plus b to the power of r plus 1 plus constant. So you have this, yeah? But r cannot be minus 1. Okay, because if you have r minus 1, you have 1 over ax plus b that will give you ln x and so on. Okay, okay, so by substituting to the formula uv minus integral v du, you have this one, you have this one, you have this one, and in the end, by using hard work, your hard work pays off, and you have the integral will give you this 2 over 3 x to the times square root of x plus 3 minus 4 times the square root of x plus 3 plus a constant. Yeah, by using hard work. Hard work. Okay, so this is alternative answer. Alternative answer. I do not want to use integration by parts. Yeah. For here, I can let u equals x plus 3. So this is square root of u. I want to use substitution technique. But what about x, this one? Yeah. If u equals x plus 3, x equals u minus 3, this one. And u is dx. So, the integral of this will become x is u minus 3 divided by square root of x plus 3 is u, square root of u. Tidy it up. Integral of u divided by square root of u du minus 3 divided by 1 over square root of u du. Okay, and u divided by square root of u, this is u to the power of 1, u to the power of half, it will give you u to the power of a half. 1 minus a half is a half. What about this one? This is u to the power of a half. 1 over this is u to the power of minus a half. So you have this one. Okay, and you can use this. What is integral of this? 1 over a half plus 1 times u to the power of a half plus 1. This is 3 over 2. Minus 3 divided by minus a half plus 1. Minus a half plus 1. This one. Times minus a half plus 1 is a half. Okay, plus constant. And then you get a half. This is 3 over 2. 1 over 3 over 2 is 2 over 3. U square root of u minus 3 divided by minus a half plus 2 is a half. 3 divided by a half is a half. 3 divided by a half is 6. So you have minus 6, the square root of u plus constant. Tidy it up a bit. U is x plus 3, back substitution. Square root of x plus 3 minus 6 times this one. Okay, so this is enough. If you have already this is enough for me. But you can simplify it further. You can do this. And, okay, so you have 2 over 3x this plus 2 over 3 times this. 2 over 3 times 3 is 2 times this. Minus this. Okay. And you have 2 of this minus 6 of this. So you have minus 4 of this. So you have this. And you have the same answer. But a shorter one. A shorter one. And more easily. So do you have any questions? So this is the first part of our lecture today. For the second part, we would like to discuss about differential equations. Okay, we will look at that at the next semester, but this is just the introduction to differential equations. Okay, do you have any question here about integration by parts? So in the end, I can conclude here. For integration by parts, you can just memorize this and choose wisely what is u and what is dv. Some questions can be worked by using integration by parts and substitution. And if you are faced with that question, I advise you to choose the simpler one, that is substitution method. Okay, so if you can do some question with both technique, I'd advise you to use the simpler method, that is substitution by substitution technique. Okay, and you have to choose wisely. Okay, choose wisely. Okay then. So this is the last part of our lecture, that is on differential equation. Okay, look at this equation, dy dx equals to x. This is what we usually call y prime equals to y. What is y prime? The derivative of y with respect to x. The derivative of y with respect to x. This is what we usually call a differential equation. This is a equation that involves derivative. Equation that have derivative. If you just have first order, if you just have one derivative, first derivative, this is what we usually call first order. So if you have this, y double prime equals to y, what is the y double prime? This is the second derivative of y. So this is what we usually call the second order differential equation. What is differential equation? Equation that involve derivative, differential. Okay, yeah? Okay, and the solution of this is e to the power of 2x. Is it true? Yes, you can just use. If y e to the power of 2x is a solution, yeah, very easy. Just substitute this. So dy dx should be e to the power of 2x times the derivative of 2x with respect to x, that is 2. So you have 2 times e to the power of 2x. But e to the power of 2x is y. So you have 2y. So it satisfies this differential equation. So this is a solution. So for differential equation, you want to find the solution of this. You want to find the solution of this. Okay, and this is not unique. This is not unique because you can multiply it with a constant, and it's still a solution. So the general solution of this is yx equal a constant times e to the power of 2x plus c. So this is sorry, no, just this. K times e to the power of 2x. This is the general solution. Okay. If you are given initial condition y0 equals k, that is what we also call, we want to find the particular solution. How do I find the particular solution? I have to substitute what is k. I want to find what is k. If k is just one number, maybe 2, we usually call this, name this a particular solution. If you have k, what we also, or this is c, a constant, we usually call this a general solution. General solution. Okay. So in the end, we would like to discuss 2 types of first order differential equation. Are there any other types? Yes, but you won't learn it in this course. Yeah, next semester you will learn about that. So type 1 that can be solved directly. What do you mean by directly, Pa? Like this. So if you have dy dx equals fx, I can multiply dy equals fx dx. So I can integrate both of this. So you have integral dy is y. Y is a function of x equals integral of fx dx. So you can do this directly. But sometimes you won't have this. You will have to use what we also call separation of variable technique. Separation of variable technique. Let's look. This is the This example is for the direct method. We'll look at the direct method. So dy dx equals x squared, and we know that y0 equals 1. Find what is yx. Okay, answer dy equals x squared dx. I just multiply it to the right hand side, x squared dx, and I can integrate both of this. Integral of dy is y, don't forget it's a function of x. Integral of x squared is 1 over 3x cubed plus constant. So you have this as the general solution of this. Okay, don't forget it involves the constant. Okay, but you know y0 is 1. So you can substitute y0 is 1/3 0 to the cube plus constant. This will become 0. Y0 is 1. So 1 equals 0 plus c. So you have yx is this plus the constant is 1. So what we usually call this a particular solution. Particular solution is true? No. This is what we usually call unique solution. Solution of this one and this one. Okay, the differential equation given the initial condition. Okay, do you have any question? This is the direct method. The direct method. You can solve this directly. Okay, but what about this one? Dy dx equals minus x divided by y. And it passes through 0, 1. You know, yeah, this is x and this is y. This is x and this is y. Find solution of this differential equation. Okay, let's see. Dy dx is minus x divided by y. I can separate y variable and x variable. So I can multiply this to the other side and this to the other side. So you have this. And then I can integrate both of the right hand side and left hand side. What is integral y dy? A half y squared plus constant. Just leave the constant. Just use the constant for the right hand side. And what was the integral of this? Minus a half x squared plus constant. So the constant just on the right hand side. Okay, yeah, you can use the left hand side also, but this is the same. So you have this one, and don't forget, it passes through 0, 1. What is this? Oh, sorry. 0, 1. So when y is 1, x is 0. So when x is 0, it will become 0 plus c is c. And y is 1. A half, 1 squared is a half. So c is a half. Then the unique solution is given by this one. Okay, pay attention. We don't have to have this one. No, you don't have to explicitly y equals something. No, this is enough. Equation enough. Yeah, so you don't have to bring this into y equal. No, a half y squared is this. This is just the solution. This is also the solution. And it is enough for me. And it is enough for your other lecturer. Okay, this one. I think this is the last one. Yes, this is the last one. Find the solution of dy dx equals e to the power of x minus y. Don't forget, e to the power of x minus y is e to the power of x divided by e to the power of y. Now I can use separation of variable. E to the power e to the y I can multiply to the left hand side. Dx I can multiply to the right hand side. So I have this one. I can integrate both. I have integral ey dy equals integral ex dx. So integral of ey dy, this is integral e to the power of square d square. So you have e to the power of square plus constant. But constant is just for the right hand side. So we have e to the power of y equals e to the power of x plus constant. So this is the solution. This is the final solution. The final solution that satisfies this differential equation. Okay, let's look another variation. Okay, if you can look at this, you can use separation of variable technique. So you have 1 over y dy equals 2x minus 2 to the power of 4 dx. You can integrate both of this. And integral of this is ln y. What is integral of this? 1 over 2, 1 over 5, 2x minus 2 to the power of 5 plus constant. And this is the solution. Okay. What about the last one? The last one, I'll give you a clue. Okay. So I can multiply it, separate the variable dy. And what about x? And you integrate this. And you will have ln here, ln y, sorry. But this one, you have to use integration by parts technique. I'm sorry. Yeah, and you can use this, yeah, something plus constant. So this is the general solution. If you want to find the unique solution, you have to have the initial condition like this, passes through 0, 1, or fy0 equals 1. If you have this one, you will have all of this. Yeah, okay. So any question? So this is what we also call integration by parts technique. So you just have to apply the formula by choosing u and dv wisely. How can I get wise? Experience. How can I get experience? Do exercises. I'm sorry, but no other way. Okay, any questions, ladies and gentlemen?
For me, it's not, sir.
Oke. Oh, ini cuma 41 sih, kemana yang lainnya? Oke. Sabina.
Wait, sir.
Yes. Yes, your name? Oh, Agnia. Yes, Agnia, questions.
Yeah, for example 5, the alternative.
Example 5, this one.
No, for the integration by parts.
Integration by parts. This
Not
one.
exact.
Yes.
Yeah, for the alternative answer.
Yes, alternative answer. Yes.
Yeah, for the x, I understand how x is u minus.
Very good, Agnia. Very good, Agnia. So you have u equals x plus 3, isn't it, Agnia?
Yes.
What is x then? X equals u.
Oh, okay. U minus 3. Okay.
Minus 3. That's why, Agnia. Thank you for your question.
I see.
Okay.
All right. Thank you.
Okay, thank you. Any other questions, ladies and gentlemen? Hauzan Almaizar, questions?
No, sir.
Okay. Si Gina kemana? Gina? Where is Gina? Gina? Si Kayla ada? Oh, Kayla ada. Si Kayla ada. Alexander ada. Ini nama siapa aja ya? 9 orang. Zafiral, okay. Zafiral, any questions?
No, sir.
Okay. Sabila Firajati Rahman. Oh, any question Sabila? Ada ya si Sabila ya. Sabila, questions? Sabila. Ryan Abdurrahman Jalins, questions?
No, sir. I think it's enough.
Okay. If you don't have any question, I think I will end up here. Don't forget to fill the attendance list. And for next